2. X minus 2 to the 5th power. Now, I can start with the 1, 1, 1 every time, or I can start with a row I remember. I need to get down to the 5th row. The second number is a 5. If I remember that we just got to 1, 3, 3, 1, if I remember that much, I can start in any row to get the row below it. So 1, 3, 3, 1. If I put a 1 here, next number is 4, and the next number is
8. 6.
6. Next number is
4.
and the next number is 1. All right, you always have 1s on the ends and then add, add, add. So if you remember the 1, 3, 3, 1, the next row down is 1, 4, 6, 4, 1. Then we start with a 1, 1 and 4 makes 5, 4 and 6 makes 10, 6 and 4 makes 10, 4 and 1 makes 5, and 1 makes, then 1's on the end, right? And again, I know I need to get to that row because this is a 5th power. I need my second term, my second number there to be the same as the power. So these numbers have to match to know which row I'm supposed to use. So notice I'm going to get 1, 2, 3, 4, 5, 6 terms to be built on this one. But I'm going to build the terms the same way I just did a moment ago. I start with my first number, 1. X is the first object raised to what power?
5th.
The 5th power. The first object always goes to the highest power, which is in the problem, which is 5. The second number, notice this time is negative 2. Make sure you put negative 2 in the parentheses, and it's going to be raised to what power?
The 0.
0. All right? So first object always goes to whatever the power of the problem is. Second object always starts at 0. All right? So that's how we build our first term. Every other term is built off of that idea. So plus, always put plus, 100% of the time put plus. Never, ever, ever put minus in between the terms. If minus happens, it happens because of evaluation. Next Pascal number is 5. I've got x, I've got negative 2. Every time I'm writing a negative because negative signs matter. X is to the 5th, we drop it to the 4th. Negative 2 is to the 0, we bump it up to the 1st. Next term we put plus. Next number is 10. X and negative 2 are our pieces. And x goes 5, then 4, then 3. Negative 2 goes 0, then 1, then 2. Next number is 10. We have an x, we have a negative 2. X is 5, then 4, then 3, then 2. Negative 2 is 0, then 1, then 2, then 3. Next number is positive 5. X and negative 2 are our pieces. X is 5, then 4, then 3, then 2, then 1. Negative 2 is 0, then 1, then 2, then 3, then 4. And our final number on Pascal is 1. We have x and we have negative 2. X goes negative 5, 4, 3, 2, 1, 0. And 0, 1, 2, 3, 4, 5. A lot to write down, but it's a very simple pattern to follow. Most people can handle that pretty quickly in this technique. Most people have difficulty with this is when you start getting these higher powers, sometimes it's a little harder to evaluate. Now, I want you to notice here we have a number to a power each time. Negative 2 to the 0, negative 2 to the first, negative 2 squared, and so on. That number to a power needs to be evaluated first because that's the order of operations. Power first, then multiplication. Power first, then multiplication. Power first, then multiplication. And so on. In each case, x is just x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, right? So if they have an evaluation, what I like to do when I start getting larger numbers here, larger powers, is I like to actually evaluate the powers. If I'm taking a negative number to an even power, I'm going to get a positive solution. So negative 2 to the 0 power is equal to positive 1. Negative 2 to the first power is negative 2. Negative 2 to the second power is positive 4. Negative 2 to the third power is negative 8. Negative 2 to the fourth power is positive 16. And negative 2 to the fifth power is negative 32. X to the 0 power equals 1. For me personally, that's how I typically do it, right there. If I have numerical values being raised to powers, I go ahead and raise the powers so I can see it. So it's just a straight multiplication. Now I don't have any powers to look at when I'm multiplying. So now when I build my terms, here's term number 1. I got 1 times 1 times x to the 5th. The second term is right here. I've got 5 times negative 2. 5 times negative 2 makes what?
-10.
Negative 10, that makes x to the fourth, right? So the numbers create the coefficient, the letter is whatever x to the power is. Next object. Okay. I've got positive 4 times positive 10 times x cubed, that makes positive 40x cubed. Next term is here. I have positive 10 times negative 8 makes negative 80 x squared. I've got positive 5 times positive 16 makes positive 80 x to the first. I usually don't write the first power, I just write x. If you write the first power, it's not wrong. And then our last term is right here. Negative 32 times 1 is negative 32. Pick the right row, write the correct answer, make it pretty. There's our final answer to this problem. Works for any power. If you have a binomial to a power, it works for any of them. As the rows get bigger and bigger and bigger and the powers get bigger and bigger and bigger, the numbers start getting larger. As you can see, 2 is the biggest number in this problem, right? Got all the way up to 80 because we have the fifth power. So again, keep that in mind that these can grow large, but raise your number to a power first, then you're just looking at multiplication. If the multiplication gets to be too large for you, type in your calculator. You know, maybe 16 times 5 isn't off the top of your head 80, maybe you type in 16 times 5 equals on your calculator, spits out the number 80, right? So again, if you need to help calculating things, use a calculator to help calculate, especially when the numbers start getting very large, because they will. All right?